Okay, we're going to go over solving systems of equation using elimination. So the first problem we started before the session cut out was 3x plus 4y equals 10 and 3x minus 5y equals negative 26. So let's look at our first step. When you're doing elimination, you want to eliminate things where the coefficients are this. You want to use the same coefficients for one variable so that way you can eliminate them when you add them together or subtract. So in this case, x has a coefficient of 3 and a coefficient of negative 3 if you subtract. So I showed you what it looks like for the individual parts of the equations whenever you subtract them. That's where my work is shown, and what you come down to is 9y minus 36. Then, once you've combined the equations with the elimination, you have a simple equation that you can solve for the variable y. In this case, it's y. Just depends on which one you're working on. So when you divide both sides by 9, you end up with y equals 4. Then from here, you want to take that y value and you want to plug it back in so that way you can solve for the x value. So you get x equals negative 2. And for this one problem, I wrote down what it looks like to actually check your work as well. But you're done. You have the x value and the y value. You have your two things you're looking for. If you wanted to check it, you just plug it in really quickly. Plug in your x value, plug in your y value, and when you solve, if you did it correctly, you'll end up with something like 10 equals 10. That means and that's true, so that means that those two numbers made the equation true. That's how you can check things. So this problem we already did using substitution before. I have that up here. There's a lot of work. It's a lot of work, and you ended up with fractions when you did it using substitution. When you do it using elimination, it's much more straightforward. So you can pause the video and look at what the solution method is using substitution. And pause, take a look at it, and then consider what it looks like using elimination. Picking the right method will simplify your work for you. It's not a matter of which one will get you the right answer, because both will. It's a matter of what works for this problem. So let's look at another example. This one is going to be slightly different because you have coefficients that do not match. So if you look, these two coefficients, 4 and negative 3, those don't work together. Or those don't, if you were to add them together, they wouldn't cancel each other out. And 3 and negative 2, those will not cancel each other out either. So what you actually have to do in this case is you have to multiply both of them by numbers first to make it a more workable solution. So if I took the first equation and multiplied it by 2, and then the second equation and multiplied it by 3, I apologize, there's a parentheses missing. So multiply this one by 2, multiply this one by 3, you'll end up with a negative 6y for the negative 6 for the coefficient of y here, and then a positive 6 for the coefficient of y here, which means that you can actually add those two new equations together. So I took this equation and I wrote it over here. And then I took this equation and I wrote it over here. So that way I can combine them. So when you add them together to eliminate your y value, you end up with the equation negative x equals 1, which we can probably tell is a pretty straightforward, simple equation. So all you have to do is solve for x from that point. Very easy. And then let me zoom out so you can see the entire problem. Sorry about that. So then you take that x value and you plug it back in to one of the equations, it doesn't matter which, and solve for y. So you get that work done, and you have both answers that you're looking for. I didn't check this one. I just didn't want to take up the time for the video. So this shows you the general thing that you'll have to do with elimination. Sometimes you'll have to multiply an entire equation by a number or multiply both equations by a number. So that way your coefficients match and you can eliminate them. Otherwise, you're doing substitution for this could make it a little more complicated, deal with fractions, or you have more steps. This is going to be the simplest method for most of these kinds of problems. So you can pause the video, get this problem down, make any notes of questions you might have. I'll give you a few seconds to do that, and then I'm going to move on to the next example. Okay, moving on. So our next example, x plus 1/4 y equals -1, and negative 4x plus 3y equals -20. When you look at this, first thing you should clock is that there's a 1/4. The coefficient is fine. It's not wrong to have a fraction, but when you look at the other equation of a -4x, if you should see that there's 4's on both of them. When you multiply one of them by 4, then you might end up with some things that match up. And that is what happens. If we multiply our first equation by, sorry, when I erased that just now, I accidentally erased this. So if you multiply the first equation by 4, you're going to end up with coefficients that do match. So I take a look here. So you end up with the equation 4x plus y equals -4, which is the transformation of this equation. Now you end up with matching x coefficients that you can then just simply add together to cancel out x, because x goes away. The 4y right here, I'm sorry, it's kind of swallowed up by the blocking, but you have 4y equals -24. I do have the work shown over here as well, which you don't have to do. You can do it all inline if you'd like. So then you have an equation with just y. You can solve that for y. Once you have the y value, you plug that back in to solve for x, which is typically the more computation intense setup here. And then you're done. You have your x and your y values. Yes, your x value is a 1/2. That's not bad. That's not wrong. Just a fraction for an answer. So I'm going to let you pause, get this down in your notes. Notice that this is the same method as the last problem. It was actually a little bit simpler because there's only one equation that needs to be multiplied. So I'll let you take a second. And I'm going to move on. So this is our last example, and this one I actually am asking you we're discussing something. It's along the same lines, but we're looking at for something different. So we want to know, what does it look like when you have different types of solutions? So you're given the example 2x plus 3y equals 7. I'm so sorry that I have that multiplied by 3 in there. Let me erase that and I'll just write it in a second. So this is your system, and much like the last example, you look at it and you say, okay, well, there's a 2 and a 6 for my x values, and there's a 3 and a 9 for my y values. If I were to multiply one by that first equation by 3, that's going to end up giving me matching x coefficients to simplify. It might even end up giving me matching y coefficients. So let's see what it looks like. So when I do that multiplication, I ended up with matching x coefficients. I also ended up with matching y coefficients. And I also ended up with matching constants on the other side of the equal sign. So all of it canceled out, and I ended up with 0 equals 0. There's no variables left there for me to plug back in and solve for something else. So I want you to think about it this way. 0 equals 0 is always true. So that means that any numbers I plug in will make this true. And if that's true, if that's the case, then any number is a solution, because a solution is just what makes the equation true. So if any number is a solution, then I have infinitely many solutions. I have every possible number. So the way you can write this is you can write all real numbers. Let me erase this part, sorry. You can write all real numbers. You can write infinitely many solutions. I don't really think that you should write just infinity. That doesn't really work. But this is a possibility for you. So when you get a solution, or when you're working through a problem and it simplifies down to this, to something like 0 equals 0 or 4 equals 4, not when you're checking your work, but when you're solving, that means that these are a dependent system where they are the same line overlapping. And then I would recommend at this point you check it. You go graph both lines and say, do they match? Are they the same? If they are, or if they do match, then that tells you that it's all real numbers. That's the solution. Every number makes it true. Okay, hopefully this was helpful. And you can pause and rewatch as much as you need. Have a great day.